You can start now.
Okay. Is it visible?
Yes, visible.
Okay. So, good evening, everybody. So, let's start from where we have left in the last session. Actually, we are discussing about the pre-processing steps, and we have mentioned that the pre-processing steps are basically about two groups. One is basic pre-processing step, another one is advanced pre-processing step. Under the basic pre-processing step, we have divided into basic, frequently used, preliminary, frequently used pre-processing task, and some other steps. So these other step today we will discuss, and these other step under whatever is coming under this is not very much frequently used in applications. Wherever it is required, they are very, very specific in nature. Wherever it is required, we'll use it. Otherwise, it is not going to be used. Okay, and also today we'll discuss the advanced part. Then we'll go for the embedding or feature part. Okay. So the first very fundamental pre-processing activity, which is coming under the other steps of the basic pre-processing, is language detection. The question is why language detection is required in NLP application. Okay, I'm giving you a simple scenario, then it will be easier for you to understand. Let's say you are a product company and you are selling your product across the globe. Now you want to find out what people are talking about your product. Means what is the review, and what you do now. Your product page is there. You may get the reviews from your product page, or you can get the reviews from the e-commerce websites where your product is listed, or from different discussion forums where people are talking about your product. You can get the information from there. Now the situation is that as uh, let's say it may not be a global product. Let's say it is an Indian product. So in India there are many steps, many states. So when you collect these reviews, people are talking in their own language also, or writing their language also. Now when you collect such kind of reviews, now how you will analyze that? So that is the challenge. This is a scenario. Now what is the complication? The complication is very simple, that as people are using their native language to write the reviews, all are not writing in English. So now if you have such kind of reviews, then how your model is going uh, to process them? Okay, because generally the model, whatever you have created, if you have created a model using English language, or it is a unimodal model using only one language, then if any other language information coming as input, your model will give you some result, but it is not going to give you accurate result. Sometimes your model will hallucinate, sometimes your model is not also going to perform in the manner what we are in it should be performed. Okay, this is the complication. And sometimes you also get some operational threat in the sense that if your model only capable of handling English, and if a new language comes which is not written in English text also, when the script is not English, okay, then your model may not parse it, your model may not tokenize it. So it will be difficult, because you see, if your model uses let's say you have a custom built tokenizer which uses space to find out that word, and if a language if a sentence from a language comes as input which do not use space. In our Indian language also we have space in our between two words we have space, but if you see Chinese, Japanese language, they don't have space. So now if you got such kind of reviews in such languages, then it is difficult for your model to process. It will give you means it will not work. So that is the operational threat. Now what is the solution? Solution is, first you have to identify what type of language being used in the text, which is going to be given as input to your model. So in any NLP pipeline, one pre-processing step you may include as the language detection. If let's say you have very sure that your model will be trained on a English language, but you are very sure that the most of the incoming reviews are in English, then you should not train a model on different languages. So you can train on a language, but you put a in the pipeline, you put a language identification part, so that when any incoming review will come, if it is not in the English language, then it can discard that. That can be done if you are sure. But if you are not sure that what kind of or how many percentage of text or review will come in different language, then you have to think differently. But this language identification is the first step. So this is one pre-processing that we have to use. There are many Python libraries available which will be used to detect the language. One very famous library is called Polyglot. You can use that library, and we will also see how Polyglot will be used to identify the language of a text. Okay, so once you identify, then you can use language specific pipeline, or you can discard it. That is up to you. So this is the first pre-processing activity that can be done under the other steps of the basic pre-processing. Next is code mixing. It is similar. Code mixing means it is the structural blending of linguistic units. In linguistic units means words, phrases, or any morphemes. Okay, and it uses multiple language within the same text. In one text, in one sentence, or in one text part, different words is written in different languages. Such kind of text is called code mixing text. And code mixing is very nowadays is very common, because people are using social media. In social media, we are writing in English, Hindi, Odia, everything you are mixing in one text. So if you such kind of text is coming, then how you will use that for your model? Okay, so that need to identify first. So that is called code mixing. And now you see here, there is a sentence. It contains Tamil, Mandarin, Cantonese, English, Malay. So different languages are there in one text. And what does it translate? Translation is, hey, when we did we always eat at the copies of one. So you see, this is the English translation, but you see different words is written in different languages. This kind of text, where multiple languages are being used to write a text, we call this as code mixing text. Okay, and why we are getting such kind of text? Because now people know multiple languages. If you know multiple languages, it is common. Fluently it will come to you when you are speaking or when you are writing, that you will switch between different languages during speaking or writing. So that's why you got such kind of text in your in any platform. Now question is, why it matters? If you have code mixing language or code mixing text, what is the problem? So why it matters? Because you see, many downstream NLP models which uses tokenizer or POS tagging or sentiment analyzer or any other module, they may misinterpret this mixed language text, and which will lead to poor performance of your model. Okay, this is one problem. Another problem, that if you have a monolingual model means your model is only trained in one language text. Now, if you have a monolingual model, then if you got such kind of code mixing text as input, then it will be difficult for that monolingual model to parse and to find out the answer for that. Okay, so where you will get? Because it's very common in social media, it is in product review, charts, and conversational data. Any kind of conversational related data, you will get such kind of problem. Okay, or a code mixing language. Now, what is the solution? The solution is very simple. First is you have to identify what kind of language each word is being used. So you just split the sentence into words, and for every word identify what is the language. Then you can normalize or translate it. So if there is any kind of normalization techniques required, which you have already discussed, you can apply that, and after that you can translate to your language which is required for your model. If your model is trained in English language, then you can transfer every word into English, translate it into English, and you can use it. No, this is one case. Another case is that nowadays different pre-trained models available, like IndicBot, MBot, your XLMR. These are the models, pre-trained models, which can be used for this kind of code mixing language, because it can easily understand and can be used for further processing in NLP. So we can use that because these models train on this type of text where different language is there in the training data. Okay, or you can create some custom dictionaries and rules to create how will deal with that. You can create a custom rules for that also, but mostly will not use custom rules. Rather, either you translate the every text into English if your model is in English, or if in any other language you translate it using translations modules, or you can use this multilingual models, pre-trained multilingual models for your task. Okay, so this is called code mixing. This is another pre-processing test. You have to identify whether your data is code mixed or not. Okay. Third one is called transliteration. Transliteration is now is very common. You may not get code mixing that much, but transliteration you will definitely get. Transliteration is what? It is the process of mapping a word from its native non-English language or Latin language into the Roman alphabet-based phonetic sounds similarity. Means if you want to tell in Hindi, but you are not writing, the script is not in Hindi, or in Hindi script is your Devanagari script. You are not writing in Devanagari script, rather you are using the Roman letters, means English letters to write it, or English script to write it. Okay. Now you see here, let's say a user writes a post using English character, but the words phonetize means the word sound is Hindi. Like you see, Mera naam Rahul hai. So here we are writing Hindi, but the script is Roman. It is not Devanagari script or Hindi script. Okay, you see here, Mera naam Rahul hai. Now this is the input. Now if you got this kind of data, then what will the problem? The problem is that even if you you got this data, this written in English characters, but they are not English words. And if you give this to your model, the model will use it, but your model is not going to perform as we are expecting. Okay. Now why it matters? It matters because users often type in Roman letters to express words from their native language. So they are using native language, but they are actually not writing their native script. Rather, they are using the Roman script or English script. Okay. So if you are writing that, then standard NLP models may fail to understand that what is their language. They will thought that it is English, but actually it is not English. Okay. Now if you give to this to your language identification module, then it will say sometimes say if it is based on script identification, then it will say it is English. Okay, some language identification softwares are there or modules are there which can identify it as Hindi, but some are there if they are script based, means they are using Unicode of that script to identify the text, then it can be easily say it is not a Hindi, rather it is English. So this is the problem. So what is the solution? And the solution is here, first you identify the language. Now the polyglot is also being used for that also. So you identify the language, even if it is written in Roman script, it can identify the language. Once you identify, then you convert that. Okay, so for converting different, let's say you want to convert this into Hindi. So there are different pre-trained models available or modules available, which you can use. Like one is Indic transcript. So you can use that to translate this English sentence, which is a Hindi sentence written in English alphabets, to the means this kind of alphabet, original alphabet of the Hindi. Okay, then you can do the normalization, validation as it is, and you can process it according to the model's requirement. So this is called transliteration. So there are three steps I have discussed. One is your language identification must for both transliteration as well as for your code mixing. Second one is code mixing and transliteration. So these three are the basic comes under basic steps when you have this kind of situation. Otherwise, if it is pure English, you don't need such pre-processing steps. Okay. Now comes, so this completes the first part, that is the basic pre-processing steps. Now we'll come to the advanced pre-processing step. Similarly, this advanced pre-processing step is also always not required. In some application it is required, in some application it may not be required. Okay, so what are the advanced steps for pre-processing? First one is POS tagging. So POS tagging is called part of speech. POS is nothing but called part of speech tagging. What is it? It is the process of assigning grammatical categories to every word in a sentence. What is grammatical category? Grammatical category, the word can be a noun, the word can be a verb, the word can be adjective, etc. So it can use means it can use the word and find out what category of grammatical information is there, whether it is a noun or not, whether it is a determiner, etc. Okay, so this is called a POS tagging, assigning part of speech tag to each word. Okay, so the process by which we are doing, we call it as POS tagging. And now why it is required? Because it will helps in understanding the syntactical structure and the meaning of the sentence. If you know that these are the part of speech for a particular word, then easily you can identify what will be the meaning. Because we know that in English, one word can be used as a verb, can be used as a noun. Now, whether it is a, then according to that, meaning will change. So, whether it is a noun or verb, that need to identify first. Then only the meaning can be well understood by the model. Okay, and for that only we are using POS tag. So now you see here, this is a sentence. One example is given: the cats are playing in the garden happily. Now, what are the tags? So this the is treated as a DT. So now these symbols, two letter word or three letter word, these are called tag sets, and there are different tag sets available. Okay, so one is pen trivanx tag set. So generally we use that pen trivanx tag set. So let's say, what is DT? DT is nothing but determiner. A and the all are called the determiner. So if you see and the, then it's a POS tag is determiner. Now cats is NNS. NN is for noun. S is for plural. If it is cat, then it will be NN. So NNS means it is noun and plural. R is VBP. VBP means verb, but in the P is present, which in which tense? So it is present tense. Okay. VBG, playing, is another verb, but it is gerund. Okay, or we can say it is present participle. Now in is here. This in is in. In is nothing but preposition. So in some tax set it is called a PP. In some tax set it is called in. Then again, the is DT, means determiner. Your garden is a noun, so it is noun. So you see here it is no S, so it is noun singular. So you see much information we can get from these POS tags. Now it is NNS, here it is NN. Similarly, happily is your RB, that is called adverb. Okay, so these are the tags which can be assigned to each word of the sentence. So there are libraries available which can be used to do that. Okay. So what are the application? So it is it is a various applications. So it is used such as in information retrieval, sentiment analysis, machine translation. So in wherever you want to give extra information about the words to the model, then this can be one extra information you found out, or you get the extra information as the tagging, then you can pass it to the model. Okay. Now question is, in which situation it should be used? Now already we have seen that in lemmatization POS tagging is required, because in the last class we have said, we have discussed that if you need to use lemmatization what? To find out the correct dictionary based root word, or best means correct lemma. So now for that we need POS tag information. That means when you pass a word, you have to pass its POS tag. Then if you pass, then only it can easily identify what should be the correct lemma or a root word. So for lemmatization, POS tag is required. So in that case, you have to use it. In named entity recognition, POS tags are required, because named entities are nothing but we'll see. This is also another step. So in named entity means to identify whether it is a person, place, or anything else, any noun. Okay, so that case, in that case, you need to know the POS tags also. Information extraction, you want to find out the information, and generally we know that the information is based on noun, verbs, or some key phrases. So if you know that what kind of, let's say The question is, who is Prime Minister of India? So you have a text. Now, who means we need that Narendra Modi. So Narendra Modi must be a noun. So if you know that this is a noun, then it will be easy to extract the information. Similarly, for sentiment analysis, in sentiment analysis, adjectives are very much important. So if it is written, the product is extremely good. So this is extremely very. So if you can get these information, then it will be more easier for the model to model it and find out what should be the correct sentiment. And in machine translation, obviously we need it, because otherwise it will difficult for the translation engine to translate from one language to another language. Is it okay? So this is called POS tagging, and this is one pre-processing task. Now, why it is required? Because for grammatical understanding, for contextual understanding, for semantic analysis, for feature extraction. And the POS tag adds some more extra linguistic information to the text before model training. So that means only giving word is not sufficient. If you can give more information about the word in a sentence, then your model will be more accurate. Okay, so that's why this POS tagging information generally we provide to the model. Okay, and when we should not use, the pure stacks is often skipped in some modern deep learning models, because modern deep learning models can learn this contextual information automatically. We'll see when we'll discuss the advanced NLP part. In that case, we'll see why we don't need pure stacking, and many things we don't need, because the feature engineering part is also different there. That will discuss. Okay, so, what is the important point here? POS tagging is used as a pre-processing when grammatical structure or context is very much important for the NLP application. Context means in which context the words has been used, because we know that one word in one context may have one meaning, in another context may have different meaning. Okay, so that's why POS tagging is very much essential. Okay. Next, second advanced pre-processing activity is called co-reference resolution. So the co-reference resolution is very important here. What is co-reference resolution? So co-reference resolution says that in a NLP, it is an NLP technique where it is used to identify when multiple words or expression in a text refer to the same word. Means you have a sentence. In that sentence, some word is used to refer to another word in that sentence, and we need to identify that that word is referring to which word in the sentence. Okay, so in simple term, it will determine who or what does a pronoun or phrases refer to. Generally it is a pronoun he, she, we, may, they, this, that. So what these words are referring, so that is called co-reference resolution, and we have to resolve it in order to correctly identify the meaning of the sentence. Okay, so it is very commonly used to replace pronouns and ambiguous reference with their actual entities to improve the understanding. You see one original text here. Let's say Rahul went to the market. After that, a sentence is he bought fruits. Now, question is, what is he? So it's easy for us to know that he means it is talking about Rahul. So this is called co-reference. He is a co-reference for Rahul. So we have to resolve it. Now, after doing co-reference resolution, he will be replaced with Rahul. Okay, and there are some other there are some methods are there which is actually going to do it. But the important part is, in order to give more correct information to the model, then we need to resolve this. Otherwise, the model may not get correct reference for he. What is he? Okay. So this is called co-reference resolution. Okay. Now, why it is used as a pre-processing step? Because in many applications, pronouns and indirect reference create ambiguity. Okay, now machines may fail to understand these kind of relationship. Now he is related to your what is that previous that Rahul. He is related to Rahul, so it is difficult for the machine to identify that relationship. It cannot identify correctly. Okay, in many cases, and generally it is common in our general ML model cases. So in that case, you need to resolve it. Okay. And question is how we'll do that. There are two ways. One is pronoun resolution, means if there is a pronoun, then you can resolve it, or noun phrase resolution. So here in pronoun resolution, it is basically mostly it is being found that Ria lost her bag, she went, she was upset. So here she is referring to Ria. So this kind of reference is called co-reference. Now what is noun phrase resolution? So here let's say Barack Obama was the president, the leader gave a speech. Now here there is no pronoun. Here it is the leader. It is another word, another noun. Now this the leader refers to Barack Obama. That is called noun phrase resolution. Another third type of co-reference resolution is called demonstrative resolution. What is it? It handles words like this, that, these, those, it, etc. So now here see the laptop stopped working. This annoyed me. So this means here laptop is stopped working. So this laptop stopped working. This total event is this. That means laptop is this. So this kind of resolution is called demonstrative resolution. So you need to identify which is referring to what, means the relationship. So there are modules available in NLP libraries which will be doing that. Okay, so what is the important part here? Now the co-reference resolution helps the NLP system connect related mentions of the same entity across sentences to improve contextual embedding. So when we are doing contextual understanding, means in which context the word is being used or the context is important for that task, in that case you need to use this pre-processing step which is called co-reference resolution. Is it okay? Next is NER tagging. This is the third one. Oh, by mistake it is written 2, it is 3. So this is 3. So it is called NER tagging. This is the third kind of pre-processing activity. NER means named entity recognition. So named entity recognition is a technique to identify and classify important entities present in the text into predefined categories, like whether it is a person name or whether it is a location, organization, date, time, money, etc. Okay, and this will help to understand who, what, where, and when. So this kind of information we can get if we tag the NER, means named entity recognition tag, along with your POS. Okay, so let's say your original text is here. Elon Musk founded SpaceX in California in 2002. Now, what are the named entities here? So, named entities Elon Musk. So, Elon Musk is a person. Now, a SpaceX. So, SpaceX is an organization. Now, California is a location. 2002 is a date. So, this information is sometimes required. Where it is required? Now when you do some kind of information retrieval. Okay, so to assign specific named entity tag to particular nouns, we call this as named entity recognition tagging or NER tagging. Then question is why is it is used and why it is important? Because it helps to understand important information. When we use NER, it will be used to extract meaningful real world entities in the text, and it improves information extraction. Most importantly, in information extraction task, this NER identification is very important. Okay, because when we get or extract information, all are based on these named entities. Okay, so that's why named entity recognition is very much important, and it improves search engines also. And question answering is also, this NER is important. And why is NER used as a pre-processing step? Already have discussed, because it is used to identify important entities early, which will help the NLP system to better understand the meaning and context of the text before giving to the model. Okay, so this is called the NER tagging, and this is the third one in our advanced pre-processing step. Is it okay? So, is there any question? So, this completes the pre-processing part. So, we have covered basic pre-processing and advanced pre-processing. And you just remember, in the basic pre-processing, the preliminary, that is the tokenization, and the frequent steps. These two are very important because they are going to be used in most almost in everywhere you are going to use, and all these other step and these advanced steps you will use whenever it is required, otherwise you don't use it. Is it okay? Is there any question on this part, or should we go to the feature engineering part? Okay, so I think there is no question. Let's go to the feature engineering part. Okay, so this is the next step in the NLP pipeline. So when we are discussing the NLP pipeline, the first one is data acquisition, second one is cleaning, data cleaning, third one is data pre-processing. So these three steps we have covered. Now we go for the feature engineering part. This is the fourth step in the NLP pipeline. So the feature engineering is again very important part of the NLP pipeline. Two things are very important. One is pre-processing, and this one is feature engineering. Okay. So what is feature engineering? It refers to the process of converting raw text into numerical representation. We call here it as features, because we know that the machine learning or deep learning models cannot understand and process the text. It can only understand the numbers or numerical representation. So what we have to do here, whatever text we have, after doing the pre-processing, the cleaned text must be converted into numerical form. Then only you can give this to the model, and the model will use it. So that is called feature engineering, means identify or convert the text into its corresponding numerical form. Okay. Why it is required? Because the text is not a structured form, and the ML model which is to be used for modeling NLP requires numerical numbers in a structured format. That's why this feature engineering step is very much important. Okay, so sometimes this representation, this conversion from text to numerical form is called text representation. Sometimes it is called feature extraction. It is also called text vectorization, because the numbers are put in a vector or matrix. Okay, so text representation, text vectorization, feature extraction, feature engineering, all are same. They are the different names for the same work, that is converting text into meaningful numerical representation. Okay, then why we need the feature engineering in text is very simple. Already we know that the feature engineering is needed because ML and most traditional NLP algorithms cannot directly understand the text. So the text data is unstructured. That's why ML model cannot use it, because they are not new in numbers. So we have to convert them into numerical form. Like here, you see human understand is I love NLP, but when you give to the machine, it will see each character as 111. So but this cannot be understood. So it need to be converted into some kind of representation. Okay. So we call it as feature engineering. And the feature engineering part is really difficult in the NLP applications, because if your representation or conversion from text to numerical form is not accurate, then whatever you do, whatever model, how best model you use, it is not going to give you good result. Okay, and let's see why it is difficult. Because feature engineering is difficult because textual data does not naturally exist in a structured numerical form. Means the data does not have any number associated with it, but there are some other data where numbers are inherently there. For example, let's take one image. So the case of an image, so we know that, let's say this is an image. Here we know that the image is consisting of pixels, and each pixel is nothing but a number, and the value of the number depends the intensity of that pixel, so that the color is appearing. Okay, so now if you see inherently, the image is actually contain nothing but it is a set of numbers or a matrix of numbers. So the number is already there, so we don't need to, when we want to use a picture as input to any ML model, already the numbers are there, so you can directly use it, or you can use some other technique also, but you can directly use it. Similarly for video, video is nothing but, what is it? It is the combination of pictures or frames of pictures. So you can convert these video into number of pictures or frames, and then again each frame contains numbers inside it, so you can use that number directly. because each number represents the whole picture. Okay. Similarly, if it is a wave, sound wave, so sound wave is also consisting of numbers. Inherently, the numbers are there, like the amplitude, the pitch. These are nothing but the values. You can count or you can compute. So you can find out these numbers and you can put that in any ML model. The ML model can learn or can use it. But for the text, there is no such numerical representation available. Inherent numerical representation is not there. That's why it is very difficult. So we need to convert them. Okay. So what it say, that machine learning models require numerical input, but human language is highly unstructured, ambiguous, and context dependent. So unlike images, where the information can directly represented using pixel values, but the text is not like that. There is no inherent representation of text in terms of numbers. That's why we need some kind of representation, some kind of method to convert these text into numerical form. Okay, so that's called feature engineering. And so what is the idea? Here the idea is turning raw text into meaningful numerical features that machine can understand. So here the core idea of this feature engineering, it's not that you have a text, you just convert to any number. You have to convert them in a numerical form in such a way that the semantic meaning of the text must be preserved in the number. That means the number itself contains some kind of meaning what the word itself is saying. And if that meaning can be captured in the numerical form when it is converted, then that numerical representation is a richer numerical representation of the text. And when you give this richer representation of this numerical representation of the text to the model, then model will be accurately performed. Okay. Now see, what are the different techniques? There are many techniques available. Okay, but we'll start from the initial techniques, the old traditional technique, and slowly we'll move to the more advanced techniques. So the techniques what we are going to discuss in this basic part is one-hot encoding, bag of words, engrams, TF-IDF, and some custom feature engineering. Custom feature engineering includes some kind of sentiment score or the number of words present in a text, or some kind of hashtag counts if it is a tweet text, or any other information which you can collect from the text. And in terms of numbers, these information are nothing but in terms of number of words, so it is a number, or number of hashtags present is a number. So you can collect these kind of numbers and you can give it to the model. Okay, this is also one kind of representation. So today we'll discuss one representation that is called one-hot encoding. So before discussing the techniques, let's see some of the common terms that you will encounter in this part. One is corpus. What is corpus? So very simple. Corpus is nothing but a kind of data set. In ML we call it as data set, but in NLP we call this as a corpus. So it is a large collection of text documents. So when the document is a text, we call it as a corpus for NLP task. Okay. So this corpus is being used for your training as well as for testing and evaluating your NLP models. Like the corpus may include the books, the corpus may include the articles or the tweets or emails or reviews or the contents of web pages. Means whatever text you collect, you can put in a corpus. And in general ML term, we call it as a data set, but in NLP, we call it as a corpus. Okay. So second is vocabulary, which is very much important. Remember, the vocabulary is very important, very simple thing, but always it is going to be used in NLP task. What is vocabulary? The vocabulary is the set of all unique words present in that corpus or a data set. Let's say you have a corpus or a data set and you want to use that for some solving some NLP task. Now, before solving or before doing anything, what you need? You need to find out the vocabulary. Vocabulary means all unique words present in that corpus, because that is important. Once you got it, then that information is to be used in feature engineering to convert them into numerical form. That's why vocabulary creation is a first step in feature engineering part. Okay. So for example, you see, let's say I have a corpus with two words, or sorry, two sentences. Let's say I love NLP. NLP is amazing. Now, if you want to find out the vocabulary for this, so I have to find out what are the unique words present. So here I, then love, then NLP, then is, then amazing. So these are the unique words. So now for this corpus, my vocabulary is this, which consisting of 5 words. Okay. So it's called vocabulary. So remember, vocabulary and corpus both are very important. Now the document. What is a document? Document is nothing but a single unit within the corpus. A single unit. Whether if it is a collection of books, now your book, one book or every book in that corpus will be one document. Or if it is a collection of tweets, so every tweet will become one document. If it is a collection of movie reviews, the data set is a movie review data set. So each movie review will call it as a document. Okay. It can be one sentence, it can be one paragraph, it can be one whole article, it can be book, it can be anything. Next is word. Word already we know. Word is the smallest meaningful textual unit in the document. That means every document consisting of words. So words is used for processing. Okay, that's why the tokenization is required. So for why we need tokenization, I have already told you that tokenization is actually important for feature engineering part. Once you do the tokenization, you can identify what is the vocabulary. Then this vocabulary can be used to create these numerical forms. So we'll see how we are using vocabulary. Okay. Now let's see one-hot encoding. How one-hot encoding is being performed. So it is very simple, very intuitive. Okay, to convert your textual data to numerical data. Already we have seen in ML discussion. Again, I am saying it here. So it is one kind of text representation for the text. Okay, so here you see one-hot encoding represents each word as a vector, binary vector of size v. Where is v? V is the number of unique words present in the vocabulary, means the size of the vocabulary. Okay, where only one element is 1 and rest are 0. Okay, and how will get this information? Very simple. In one-hot encoding, each word W in the corpus vocabulary is given a unique ID. That means first you identify what are the vocabulary. Once you got the vocabulary, give a number to this vocabulary. That is called the index or ID of this vocabulary. Okay, once you do that, next step is then each word will be converted into a vector whose size will be the size of the vocabulary. And in that vector, only one position, the ID position of that word will become 1, the rest position will become 0. Okay, and once you got these representation, then if you have a sentence, you just put every representation of every word, then you will get the representation for the sentence. Okay, so let's see step by step. It will be easier to understand. So let's say I have a toy corpus which has 4 documents: D1, D2, D3 and D4. One first document is dog bites man. Second document, man bites dog. Third document, dog eats meat. Fourth document, man eats food. So my corpus, my data set contains these 4 sentences. Okay. Now what we'll do? The first step is creation of vocabulary. Remember, the vocabulary creation is important. Even if in advanced NLP task also, this vocabulary is very important. So first we have to create the vocabulary. What is vocabulary? Vocabulary is you have to identify unique words from this corpus. So now we have identified these are the unique words: dog bites, man, meat, food, eats. So these are the unique words. Now what is the size of the vocabulary? So size of vocabulary is 6 because there are 6 unique words present in the vocabulary. So we call the vocabulary size as 6. This is the first step. Once the vocabulary is created. Now second step, what will do? Now you assign one ID or index to each vocabulary. So here I have given, you can give any number to anyone. There is no means ordering is not important. Okay, bites can come first, dog can come next also. There is no ordering. So here I am giving dog as ID 1, bites as ID 2. It's kind of roll number, you can think. So dog as ID 1, bites as ID 2, man as ID 3, meat 4, food 5, eat 6. So these are the IDs. Now we have converted our corpus to vocabulary, which is nothing but unique words, and again we have assigned one unique ID to each of these vocabulary words. Okay. Now next step, that how it will work. The next step is, now every word will be converted to a vector. What will be the size of the vector? The size of the vector depends on the size of the vocabulary. Now you see here my vocabulary size is 6. As my vocabulary size is 6, that means every word will be converted to a 6 unit vector. Means the vector length for every word will be 6. Okay. So now you see we have to create a 6 element vector. Now for the rule is very simple, that put 1 at the word's index position and 0 everywhere. Now what is the dog? So here you see the index or ID of dog is 1. So ID of dog is 1. That means for the sixth position, because the vector contains 6 values, so out of the sixth position, the first position, because for the dog ID is 1, so one position will become 1, rest will be 0 for the dog. Similarly for the bytes, as the ID is 2, so the second position will be 1, rest all position will be 0. And similarly you can convert every word to its corresponding numerical vector. So you see dog ID is 1, so it is 1, rest all 5 position is 0. Similarly bytes is ID is 2, so your second position is 1, rest are 0. Man ID is 3, so third position is 1, rest are 0. And similarly all of them. Okay, now every word is converted into numerical form. Now you see, now question is we have to convert the documents. So let's say take the first document, so that is D1. So here D1 contains dog bites man. So dog bites man, it has 3 words. So we have to convert these 3 words into their corresponding numerical form. So we have already found out in this previous step. So dog is 1, all are 0. Bites is 0, 1, next all are 0. Man is 0, 0, 1, next all are 0. You put everything in a vector. Now the total is this matrix. So this matrix is nothing but, so here the things are not there. This one. So okay, so here you can put like this. The brackets are not there. Okay, the brackets will be there. So you will get this is comma, this is comma. You will get a matrix, and it is the vector representation for this document. Okay, now easily for other documents D2, D3, easily you can convert. This representation is called one hot encoding. Is it okay? Anyone has any doubt on this? How to convert uh, your corpus to one hot encoding?
सर
Yes, yes. Ask.
सर जो 10 का पोजीशन है वो अपने हिसाब से लेना होगा ना, कैसे?
नहीं नहीं, ये जो 10 का ये पोजीशन है, ये you see first what you do, you have the words, you put the words in any order. There is no ordering. You put according to your will and assign one unique ID starting from 1. Okay. So let's say you want to create a list like that. Bytes will have 1, dog will be in position 2. So for that, the bytes here it will be 1 all 0. For dog it will be 0 1 all 0. समझ में आया?
यस सर, यस सर, यस सर.
Ordering is not important. You can put according to you, but whatever order you have fixed in this step, or the ID whatever you have fixed, accordingly you have to put the numbers.
Okay.
Is it okay?
Yes sir.
Okay. So this is a very simple representation, or we can say it is a simple form of converting text into numerical form. What is the advantages? Let's see its advantages. Now this is a basic and very powerful technique for converting the categorical text into machine readable numerical form. Why? Because it is simple and intuitive to understand. Very simple and easy to understand. Anyone can understand that, yes, the position you know, this is the ID of this word, and in that ID you will have only 1, rest all are 0. Okay, this is very simple and easy to implement. Also, implementation is not that much difficult. Easily you can write a very small piece of code to implement that, and I will also discuss today how we will implement that. Okay. And there is no mathematical complexity involved. No mathematical statistical calculations are required to do that. Very simple. Just identify the position, put 1 in that position, rest all will be 0. Very simple one. So it is easy. But if your corpus is small, means like you have 10-20 sentence and your vocabulary size is also very small. Let's say 10-15 words are there in your corpus, then it will be easier to use one hot encoding. But in practice, you may not see a corpus of such tiny vocabulary. Generally, the vocabulary for a corpus may be in hundreds, because there, if you have 10,000 movie review, if you take as a data set or a corpus, in that you may get 500 unique words. Okay, so for that it is not quite easy to implement that. Okay, so it has quite a lot of disadvantage. The advantages is quicker, smaller, easy to implement, intuitive to understand, but it has lots of disadvantage. That's why nowadays this one-hot encoding is not being used as a text representation anymore, because this is the foundation. So that's why we have read it. From this, we will go to the next one. Why it? What is the disadvantages? So first one is it is high dimensionality and sparsity. What is high dimensionality? Think a situation. You have a corpus of 50,000 words. You have a vocabulary of 50,000 words. Now imagine what will be the size of each word's vector. So the vector will be 50,000 and only one position will be 1. Rest all 49,999 position will be 0. So it will be very sparse. Okay, and representing a very highly sparse vector in memory will take much more memory from the system, and also difficult to process. So this is one difficulty or one disadvantage. This is the disadvantage, very common. More dimension, and all position do not contain value. Only some one position contain value. Rest all are 0. Second, vocabulary, variable length representation. This is again another problem, very prominent problem. That you see, if your sentence contains 3 words, then the size of the representation, if you are using the previous example, that size is 6, so there will be 3 into 6, 18 values. Okay, the dimension will be 18. But imagine if you got another sentence which has 4 words, then the size will increase. So there is no uniformity, uniform representation for your document. If a document contains same size of words, then it will be easy. But generally in practice, we may not get same size word or same number of word in every document. So if you want to use one-hot encoding, some representation will have some amount of values, some other representation will have different amount of values present. Okay, so and if you do that, what will happen? Your learning algorithms in the down to create the model, the learning algorithms may not be easy to implement this kind of variation. Always the learning algorithm try to get the fixed representation for every document. If you cannot give fixed representation, then many learning algorithm cannot handle it. Okay, this is the second problem. Third problem, no notion of similarity. This is very important, and this is the one problem which actually prevalent in all the basic representation what I have discussed, what I have mentioned here. What is similarity? Now you see, the core idea of numerical representation of text is that the meaning of the text must be represented in numerical form. It's not that directly convert the numerical form and that meaning is not there. So how will represent meaning? One way of representing meaning of each word is called similarity measure. That means if you have 2 words and their meaning is similar, then their representation in number must be similar. If you can do that, then I can say the meaning is preserved in the numerical representation. For example, let's say king and queen. So king and queen are related words. So if king is represented by a 6 length vector and queen is also represented by 6 length vector, then these two vectors must be close to each other in the space, 6-dimensional space. Okay, and if they are close, then we can say that they are similar in meaning, so that's why they are close in numerical representation also. But if they are not close, then the meaning is not represented in the representation of vectors, so that is not a good representation. And in your case, in our this one-hot encoding case, none of them are similar because it is orthogonal. Orthogonal means if you find out the cosine, there is a way to find out the similarity. I will tell you, that is cosine similarity. If you use cosine similarity, you take any two one-hot representation vector of any two word, it will be 0. It will come as 0. Means they are not similar. But we know that king and queen are similar. Let's say apple and banana is similar because they are fruits. Okay, your apple and king may not be similar. Okay, apple is a fruit, king is a man, so they may not be similar. So the similarity, notion of similarity must be represented in the vector. If you can capture it, then it will be easy for the downward task to use it betterly. But in case of one or 10 coding, as all the you take any two representation, they are orthogonal. That's why there is no similarity. So similarity measure is not there. Okay. Fourth problem is out of word vocabulary. It's called OOV problem. This is a very common word, you remember. OOV means out of vocabulary. Out of vocabulary means, let's say you have created a vocabulary. In the previous example, if you see, you have created a vocabulary here, that is dog. What is that? Dog bites, man meat, food and eats. This is the vocabulary. Now if you got a new sentence and you have represented that, now if you got a new sentence, let's say man eats apple. So man, yes, man is there, so I can get its representation. Eats is there, so I can get its representation. But apple is not there in the vocabulary. As it is not there in the vocabulary and you cannot find its id, so we cannot convert them into numerical representation in this 104 method. So it is called out of vocabulary. If you got such kind of word, then there is no way you can represent that word in one hot encoding. So this is another problem. Okay. And that's why, due to these disadvantages, as it is seldom used today. So generally we are not using it. Okay. So this is called one hot encoding. Now the question is how the similarity will, I've told now the two words will be similar. How will measure the similarity? So there is a method called cosine similarity measure. So means we will find out the angle between two vectors. We know that vector has a direction and a length. So if the angle between these two, so not this one, this is wrong. The angle is here, this angle between, let's say a is a word, b is another word. Let's say a is a dog, b is a cat. So here dog and cat both are animals, so they will be represented by this vector. So let's say this is the vector, this is the vector, and the angle between these two vectors is very small. This theta is very small. Okay. So if the angle is small, then we can say these two vectors are similar, or these two words are similar. How will find that? Now you use this cosine similarity measure, that the cos theta is a dot b divided by mod a and mod b. Okay, it's called magnitude or length of a and length of b. If the angle between these two are greater, means between these two word representation is greater, then they, so this similarity measure can be used to identify or find out whether two words which are represented in a numerical representation. If you see one hot encoding, you see cat b is your guy is let's take two examples. Very simple. Let's say dog, this dog and this bites. If I take, then the formula is a dot b divided by mod a into mod b, or length of a into length of b. So here a is dog, b is your bites. So if you do the dot product, means this dot, then 1 into 0 is 0, 0 into 1 is 0, 0 into 0 is 0, so it will become 0. The numerator part will become 0. So as the numerator part will become 0, so the whole value will become 0. That means it is orthogonal. When it will be 0, cos theta is 0 means for 90 degree, so it is 90 degree. So this is cos theta. So if theta is 90 degree means they are totally orthogonal. That means they are not similar. Okay, so this is the problem. Even if you see food and meat, they are actually some similarities there. But even if you calculate the similarity cosine, one hot encoding is not capturing the meaning of the words. And capturing the meaning of the word is the core idea of representation. If you got any representation which is capable of capturing the meaning of the word into the numerical representation, then that representation we have done lots of improvement on this representation, people are still working that how effectively we can capture the different meanings of words in the numerical representation, because ultimately the numbers are to be used by the model, and if the number does not contain the meaning, then there is no other way to provide meaning to the model. Okay, so that's why it is very important to create representation which will contain the meaning. Okay, so I think today we'll stop here. So engineering, whatever other three parts in the next class. Is there any doubt in today's class? Anyone has any question? Okay, so I think there is no question. So let's discuss the whatever we have discussed today. Let's go and do the answer. Is it visible? Anyone?
Yes, sir.
Okay, okay. So let's see. Just a minute. Ah. So today what we'll discuss, the parts what we have discussed today. So in the last class we have not done the tokenization. So today we'll do that tokenization also. So for this we need some libraries. One library NLTK, another library is called Spacey. That is also important library. And I have used the index transliteration, lang detect, and some other libraries also required. So first you need to install them. If it is not there, you need to install them. So let's run this. So let's install. Okay, now we have to import them. So import NLTK, import Spacey, and I've already told you that there are inbuilt tokenizers. One is sent underscore tokenize, another one is word underscore tokenize under the NLTK dot tokenize module. So the sent underscore tokenize will do the sentence tokenization, word underscore tokenize will do the word tokenization. So you have to import them. Okay, but only these two are not sufficient to do the tokenization. For these two to work, we have to download two other required resources. One is called PONCT, that is used for word tokenize, and averaged underscore perceptron underscore tagger, that is required for send tokenize. So these two extra resources need to be downloaded from the NLTK. So that's why you have to write NLTK.download PONCT and NLTK download averaged perceptron tagger. So along with this import, we need to download these two. Or if you only import this and try to use send tokenize and word tokenize, it will not going to work. Okay. And for Spacey, we have to use a module or pre-trained model that is called Encore Web SM. What is this Encore? En means English. Core means it will try do the core NLP tasks like all pre-processing tasks. Web means this model is trained on web data. SM means it is a small model. Okay, so you just load this. Okay, so let's load it. Okay, Now let's discuss sentence tokenization. So for sentence tokenization, what we need? We need this sent underscore tokenize, and also we need to download this one, this second one, average perceptron tagger. Okay, so already we have done that. So now let's say this is my text. This text contains three sentences. Dr. Sharma visited Delhi, full stop. He gave a lecture on NLP, full stop. Students enjoyed the session, full stop. Who is Mr. John? Okay, and question mark. Let's say this is the text. So what you do? First you call the sentence tokenize and pass the text to this, and it will automatically tokenize it and return the list of tokenized sentence, and I am storing it in the sentences. And when you print it one by one, I am printing here. So that is, I am taking a for loop, because directly you can print it, but here I am taking a for loop. So for I sentence in sentence and one, so for every sentence it will be printed like the sentence one, then what is the sentence. So you see, just to do it, what happened. Oh, Pong tab. Sorry. Another thing, you need to download this Pong tab is also need to be downloaded. Not only average, this third one is required also. Pong underscore tab. So you just to do that again. Now you see, Dr. Sharma visited Delhi, sentence one. He gave a lecture on NLP, sentence two. Students enjoyed the session, sentence three. Who is Mr. John, sentence four. So there are four sentences. Quite easily it can identify. There is no problem. Okay. So for a basic task, this tokenizer can be useful. Okay. Now let's do the word tokenization. So for word tokenization, again we have a word underscore tokenize. So you call that word underscore tokenize, pass the text, it will return the list of words, and you just print them. So let's say first text, let's say NLP is very interesting, there is a exclamation mark here. Okay, and I'm passing text. So when you run it, you'll see NLP, then second is, then very interesting, and this exclamation mark is also act as another token. Okay, and I've already told you there is a problem. Okay, so let's see what is the problem. Let's say this is text one. Text one contains 133 pound. This is the pound symbol, is the cost of a pen, and $100. This dollar symbol is the let's say write it the is the cost of a copy. So if I want to tokenize it, this is one. Now you see, for pound 133 it is returning one, but here for dollar 100 it is returning two token. So this is the problem, because dollar 100 should be one. Okay, so this is a problem available is there in the NLTK. Let's see another one. This one already we have discussed. O apostrophe S, Neil is a good man. So if you see, O Neil should be one token, but if you see you give text two, now there will be three tokens. So O is one, this apostrophe is one, Neil is one. So this is the problem. But still, in many cases, this word underscore tokenize can be helpful. Okay. So this is the job of tokenization. Now come to language identification. Today's topic, what we have discussed first, is the language identification. So for language identification, we have to use polyglot. So if it is not there, you need to install it. Not only polyglot, along with that, you have to install PyICU, PyCLD2. So these two things, three things you need to install. So let's install it. How to install? Pip install. Okay, and in notebook, if you want to install, then you have to give this exclamation mark before pip. So the polyglot library can identify up to 100 languages, 100, because it is trained on 100 to identify 100 different languages. So we'll see. Just taking time. Okay, so during that time, let's discuss. So what you have to import now from polyglot.detect input detector. This detector method is to be used to detect the language. So here I have given three sentences. So here sentence one is in English. I love natural language processing. Sentence two is English and Hindi. One NLP, only one word is English, rest all are Hindi. मैं NLP सीख रहा हूँ. and text 3 is in Odia. ନିଜର ଭାଷା ବ୍ୟବହାର ଜଣକୁ ମହାନ କରିଥାଏ. So let's see whether it can detect it or not. So first what we have to do, first we call the detector method, pass the text 1, then we call the detector method, pass the text 2, call the detector method, pass the text 3, and I am the names will be written in and collected in this variable detector 1, 2 and 3. So language of text 1, so detector 1 dot language dot name. See, this detector 1, if you want to just directly print it, you will not get. So the detector 1 is object which contains a language then name. So detector 1 dot language dot name will give you the name of the language. Okay, and also there is a code available, language code. So if you want to use the language code, so that is detector 1 dot language dot code. And also confidence, what will be the percentage of confidence or probability confidence that this is this language. So there is a detector 1 dot language dot confidence is also there. Let's run it. So if you run it, you see first one is English, correctly identified, second one is Hindi, correctly identified, third one is Odia, correctly identified. And if you see detector 2 dot language dot code, detector 2 is text 2, that is Hindi, so it is returning the code as HI, and its confidence score is 85%, means with 85% confidence the detector module detect that it is Hindi. Okay, so in this by using polyglot you can easily detect the language. Next, come to the code mixing. So code mixing, let's see here, this is the text. It is written in Kal meeting hey bro. So your meeting is in English. This is both as well as transliteration and code mixing. So your Kal is Hindi, hey, and bro is again English. So this is a code mixed. Now you see this one. Now if you apply this code mixed to do the transliteration, how will do that? So this code mix also you can pass to the this detector module also, it can be identified what type of language it is. Okay, so that can be done. For transliteration, if you are using your Hindi text and you want to transliterate with other text, transliterate means it is written in English, the script is English, but the content is in Hindi or Odia. So how will do that? So there is a module called Indic transliteration. So just import that from Indic transliteration, import sans script, and index transliteration dot Sanskrit import transliterate. So let's say I have two text. Text one, text it is मेरा नाम राहुल है. Text two, तुम घर कोउठी. Okay, I have written in this one is Odia, this one is Hindi. Let's see. So Hindi text. So I will use it. Now you call the transliterate, this transliterate method, pass the text, then pass the transcript dot itrans. Okay, and also pass what script you want to use. So as it is Hindi, so we have to use Devanagari. So Sanskrit dot Devanagari in capital letter. Okay, now it will converted into Hindi, and when you print this, you will see this is giving me Hindi. मेरे नाम राहुल है. Okay, let's do it for Odia. So for Odia, you have to write Sanskrit dot Odia. Okay, and let's comment this one, and let's use text 2 here. Let's see whether it is printing Odia or not. Now you see, it's Odia. Make it Odia. Odia. So the Odia script is wait. Just a minute. This ODI script is Tuma Ghara Kouthi. So a little bit wrong is there, but here it is Kouthi, Thi. So that's why it is giving Thi. Okay. So this is the way this module you can easily use to translate it from our Indic language, which is written in English, to its corresponding original form. Okay. So it's called transliteration. Let's come to the POS tagging. So what is POS tagging? Already we know that we have to tag every word its corresponding grammatical form, that is whether it is noun, verb, adverb, etc. So for that in NLTK we have a POS tag function, and for that what we need to download? We need to download this one, averaged perceptron tagger English, because we are going to use English language. So first you need to download it. Now let's say this is my sentence: the quick brown fox jumps over the lazy dog. Now first you need to tokenize it. So call the word tokenize, pass the text, it will return the tokenized word. For each word I have to find out the tag. So now call the nltk.pos underscore tag, pass the list of words. So when you pass the list of words, automatically it will tag each word and it will return another list. Okay, and when you print it, you see the is DT, quick is JJ, brown is noun, fox is noun, jumps is verb, over is preposition, the is again determiner, lazy is again the adjective, dog is again noun. So this easily, quickly, it can identify what is the POS tag. So we can do it using nltk.pos underscore tag. Is it okay? Now let's see the co-reference resolution. How will do that? So for co-reference resolution, we do not have any library in the NLTK. That's why we have to use another module on another library that is called Spacey. Okay. So let's say Rahul went home. He was tired. This is my sentence, and I want to resolve it. So that means after resolution, it will return me Rahul went home, full stop. Rahul was tired. Instead of he, it will refer to the Rahul. Rahul will be replaced here. Let's see how we will do that. So this is my text. Rahul went home. He was tired. So first you call the NLP. What is NLP? So here you see in the beginning we have already executed that one. This one NLP equal to spacey.load encore web sm. That means this encore web sm, this is a pre-trained module which contains many tasks, or which can solve many tasks, and that is written present in NLP. So we just use NLP. So just using that NLP and pass the text. So for co-reference resolution, what we have done, we call that NLP and pass the text, this text, and it will return into the doc. So now when you do this print token in doc, token.txt, if you do that, now what will see? You will see that these are the tokens, but we don't need the token. This is the tokenization. Token is there, but what we need? We need that he will be replaced with the Rahul. So how to do that? Now for that we need that another function. I just forget. I have not mentioned here. Let me see that function. So just a minute.
So whatever things Sarah is covering today, okay, those things we can implement in some low resource languages. Same thing, like your NER, language detection. You can use some other methods like your SBM decision tree. Those also you can use to detect or classify. Okay, but that is for the low resource language, not for the English, French, like that. So work has already been done. So we can do. So we are going to give some small assignments after we are going to complete the this workshop. After completing this basics, then workshop, then only we are going to give this type of time. So that what at least one work can be we can do. Then we'll think for the publication whether the depending upon the quality of the work, we'll think what can be added in that project so that we can go for the publication. But the same thing we have to implement for the low resource. Am I right, Nanjan?
Yes, sir.
Low resource means I am telling very low resource. Like African continental languages are there, local languages are there. We have many tribals are there in Kis. We can take those Santali, Ho, Kuvi, Mundari, those languages. Okay. So how we are going to implement the same thing there? And definitely not only by calling one to this library functions, but we have to go for the ML algorithms also. We have to implement that one.
Okay.
And
So the core.
yes.
Yes, sir. Yes, sir.
No, continue.
That co-reference part, I will need to install another thing. So let me. I will put that in the in this notebook. So let's go for the next one. That is just a minute. Where is my notebook? Okay. So let's go for the end year. That co-reference, I will put this function because I need to install another library here. Without that library, the space will not work alone. Okay. So let's do the named entity recognition. So in named entity recognition, it is very simple. You just call the NLP from the specie. It will give you the docs. And here there is a attribute present in the dog that is called a label. So here what I am doing, I am taking each word from this doc.ents, and it will print the corresponding text, ent.text, and also it will present its corresponding label. Label means it is named entity. So when you run this, you will see this task, this text is Elon Musk founded SpaceX in California. You will see Elon Musk is person, California is GP. Now this SpaceX is not going to be recognized here because the module what we are using, that simple SM model, so that SM pre-trained model does not train on this data. That's why this SpaceX is organization, it is difficult to find that. And also California is not here, it is not giving. So this is the small problem with the existing libraries. That's why sometimes you have to create your own NER tags and POS tags. Okay. So this is a complete pipelines. All these things we have mentioned here. Just you can do that. So this is the exercise. I will give you one thing I need to discuss. That is the one hot encoding part. I think we'll discuss tomorrow when we'll cover other three. So simultaneously we'll discuss all these four feature engineering tasks. Okay. So is there any problem? Any question?
Yes, any queries from your side? But you just practice it, okay? Lots of programs are there with me and with Answer also. You just try to practice this thing, then only, because see, whatever problem will take, the code can be available. The main challenge we have about the language compatibility only. Otherwise, if you find
Yes,
the
sir.
code from GitHub anywhere, you will get the code. ChatGPT is there, you can get the code. Only thing is, one challenge is your GPU. If we will take, as we are trying to implement LLM, GPU is definitely required. Another challenge is your language compatibility. And
Language
lots of
compatibility.
programs are there. So try to solve with us. We are also want to be part of that one. Okay. But whatever things covering basics, you just first complete those things. That is required.
So this was important. So that's why we are covering it, because once you understand all these concepts, then when we discuss the advanced part, then it will be easier for you to connect it.
Yes, yes. Okay, any questions? No one having any no questions? Upasana, Prajakta, Sandini, Anurag. Nobody having any questions? Okay, okay then.
Okay, sir.
We should stop here. I will upload this video by tomorrow morning. So yesterday video also has uploaded today only. You can check that one. Okay, and
Yes,
try
sir.
to solve the basic this exercises. Okay. Thank you, Nansha.
Thank you, sir.